So let's talk about the network operating system. So basically an easy way to understand would be your college. I know that this is Corona time and probably you'll not be going to college, but you can imagine if you've never gone to college and this is the first time and then you do not understand this. So your computer labs, you would remember there are computer labs. So there are like 100 different computers in that or 50 different computers in that lab. In the lab, there's a very large computer that's that's managing the other computers and then those computers are connected in a network, maybe in a cyber cafe also, right? There would be a master computer that would be connected to all the other all the other subcomputers as well, right? So in a typical computer lab, we may have 100 to 200 systems connected to a server. This server provides additional function to these systems which are networked to the server, and then these functions may include the access of the memory, files, printers, scanners, and software. So let's say with every system, printer is not connected, but with the master system, the printer is connected. So I am not connected to my system. The printer is not connected to, let's say, my system, but I can still print it because my master computer is connected, and all of them are communicated via a single network. So a network could be anything, a mesh, a hub, different versions of it as well, right? Now, one of the most typical features of the network-based operating system is that you can check the configuration of any other computer systems in the network. That creates a lot of transparency in computing capability and computing and the computer and does these systems are known as, not does, it's thus are known as tightly coupled system. So loosely coupled system, I get word distributed because these are not connected by physical wires, but network system mostly are connected with physical wires, so which is why tightly coupled system, very important keyword. I guess this is the most important thing. Network system, you would remember what these are. It's very easy, but the word tightly coupled here is very important. Now, in the same video, let's talk about real-time operating system, that is RTOS. Now, these are very, very important. So, for example, all the systems that are there in nuclear power plants are RTOS. Not all the systems. The main system which is controlling the nuclear power plant is RTOS. Or maybe the main system is, let's say, the Tesla autopilot system. Or not the main system, probably, let's say, the accident avoidance system is the RTOS. So a real-time operating system, or RTOS, is an operating system that is intended to serve the real-time application, that is the process data as it comes in, typically without buffer or delay. So don't do anything at all. Do not do anything at all. Just make sure that as soon as the data come, you just implement it. Don't do anything like prioritization. Don't do any batching. Don't do anything. Data comes, just give. So the processing time requirements, including any OS delay, are measures in tens of seconds or shorter increments of time. A real-time operating system is a time-bound system which has well-defined fixed time constraints. So, for example, let's say somehow in the nuclear power plant, the reactivity is increasing, right? And by so much that there could be a blast as well. So there needs to be a system that manages all of those inputs and takes a decision instantaneously, that its only job is to manage, let's say, the number of rods, the level of reactivity, let's say the input amount of whatever uranium, etc. are there, and then it's not doing anything else. It's just measuring 3 or 4 different things, and that's it, right? Now, again, in the case of Tesla also, it's the one of the most important thing there as well. So Tesla, the most important thing there is there's an accident that's going to happen. You can see a car. It's like, okay, this is too late now. I have to activate brakes, or I have to activate speed up, or I have to activate move right. So the whole human control will be there. But you've seen some videos wherein human is driving, the self-driving or the autopilot is not enabled. But let's say there's a car that's coming. So the system of the Tesla is so good that it overtakes, the artificial intelligence overtakes the humans and turns or stops or does anything. So accident avoidance. So that's basically the real-time operating system. There are two kinds of system, which is hard and soft. Hard is where the time constraints are very strict. In example, in the case of Tesla autopilot system where they are hard RTOS and must respond in the fixed milliseconds of time to avoid fatal accident. Softwares where time constraints are not so strict, example Microsoft microwave OS, so where 1 or 2 milliseconds delay will not cause overheating of the food, right? So that's pretty much about the real-time operating system. In the case, we'll look at desktop and handheld devices. Thank you so much. I'll see you up ahead in the next video.